Okay, so as promised, last time we looked at Bernoullis. This time we're going to look at multiple Bernoullis. Okay, in other words, we're going to look at binomials. Okay, so let's just look at that really quickly. And in fact, the name binomial is very important and kind of makes sense, and you'll see why later. All right, so first of all, if a Bernoulli is repeated multiple times, so if a Bernoulli trial, so one where there's only two outcomes, is repeated multiple times. Okay, yeah, it is important to note that the trials are independent, so the probability of success at each trial stays the same. Okay, so the trials are independent. Okay, that's spelled correctly, hopefully. For example, you flip a coin multiple times, or you, looking at a previous example, swing a bat multiple times. Okay, so just stuff like that. Okay, nothing that out of the world. So just doing the same thing multiple times. Okay, such an experiment where you do a Bernoulli multiple times is a binomial experiment. Okay, and because we are interested in variables, okay, we let x is the number of successes in your experiment. So that would be the number of heads, for example, or the number of hits, number of sixes after rolling the dice a number of times, okay? So if you let x be the number of successes, then x is a binomial variable, binomial random variable, okay? All right, cool. So, for example, if we have if we have a coin, we flip it 5 times, okay? So the number of heads or the number of tails, depending on what you call a success, all right? The number of successes after 5 flips. So x can be equal to either you get 0 heads, 1 head, 2 heads, 3 heads, 4 heads, or all 5 of them are heads, okay? So your number of successes, your x, can be 0, 1, 2, 3, 4, or 5, okay? So, or for another example is if you have a spinner, okay, if we have a spinner that looks like this, for example, that is a horrible square, but it does the job, where 3 parts are shaded as blue and 1 part is shaded as white, okay? Then you can say a success we define is landing on a white, okay? And then if we spin it 4 times, so we perform the Bernoulli experiment 4 times, making it a binomial experiment, okay? X is the number of whites we get, okay? So X can be 0 whites, 1 white, 2 white, 3 white, or 4 whites, okay? So that is just kind of how binomials work and what the binomial random variable can look like. So now let's do something that we've been doing this whole time. Let's try and find some probabilities for x, okay? So if x, to find probabilities, what we are going to do, first of all, is we are going to make a tree. Usually in these cases where there's a limited number of outcomes, it is good to make a tree. So let's just start with that. first try, you can either get a blue or a white. Okay, if you get a blue, the probability of that is actually, I'll just draw blue and white lines in. So if you have a blue, or you can get a white. Okay, and the probability of getting a white is 1 on 4. Probability of getting a blue is 3 on 4. Okay, look at the spinner. Okay, at each of these, then you can have either a white or you can have a blue. You can have a blue or a white. Okay, and that keeps happening. And I should have drawn a bigger tree. I'll just fix that really quickly. Okay, let me just make that a bit bigger. Okay, so the probability here is 3 on 4, and the probability here is 1 on 4. Okay, and for the second spin, again, the probability stays the same. All right, and then stays the same for the third spin and the fourth spin. And basically, I'll just really quickly fill the tree in up until the fourth spin. All right, so let me really quickly just do that. Okay, so let's just fill the probabilities in. Okay, 4 on 4, 1 on 4. Okay, you got your 3 on 4, 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 3 on 4. Okay, cool. So now that we have our tree, all right, where each time you spin, you can either get a white or a blue. Okay, and yeah, so let's now start calculating some probabilities. So the probability that x equals 0, so that you get 0 whites, or in other words, 4 blues, is you get a blue on the first one, blue on the second one, blue on the third one, and then a blue on the fourth one, which is equal to 3 on 4 times 3 on 4 times 3 on 4 times 3 on 4. Okay, and sorry, which is just equal to 3 on 4 to the power of 4. Okay, which gives you, I believe, 81 on 64 times 4 is 256. Okay. Now, the probability that x is equal to 1 calculated in a similar way is you get one white, so you can either get 3 blues, 1 white, or you can get 2 blues, 1 white, and then a blue, or you can get all that sort of things, and you can just keep finding ways. And basically what you get is, in the end, what you get is this. You get either the probability of 3 blue plus 1 white, or you can get probability of 2 blues plus, and then a white and then a blue, or you can have a blue and then a white and then 3 blues, or you can have, oh sorry, this should be 2 blues. All right, and then you can have the probability that you get a white and then the remaining 3 as blue. All right, so if you calculate that out, okay, that would give you 3 on 4 cubed times 1 on 4 plus 3 on 4 squared times 1 on 4 times 3 on 4 plus 3 on 4 times 1 on 4. That's a lot of 1 on 4 and 3 on 4. But yeah, that's just kind of how working with probability often looks like, okay? But don't worry, you're not going to have to do this too much because we're not going to use this to try and find a formula, okay? But for now, 1 on 4 times 3 on 4 all to the power of 3. Now, if you notice, there's always 3 3 on 4s, okay? And 1 1 on 4. So you can generalize that to 3 on 4 cubed 1 on 4 times 4, okay? And then moving on, you have your probability that x equals 2. There is even more ways to get that. You can get 2 blues and then 2 whites, or you can get a blue, a white, a blue, a white, or you can get a white, a blue, white. So there's many possible ways to orient that. If you count all of them, this is what you will get. Okay? And similarly, if you do this, this one ends up being 4 times 3 over 4, 1 over 4 cubed. And last but not least, the probability that x equals 4 is simply 1 on 4 to the power of. Okay, so there you have it. These are all the possibility or probabilities for every outcome. So we have the probability distribution. Now, here is something important to note whenever you see something like this: 4, a 6, and a 4, or a 3, 1, 1, and a 3, or a 1, 5, 10, 10, 5, 1. Hopefully this is ringing a lot of bells. It is, in fact, Pascal's triangle. And when you have Pascal's triangles, you have combinations. Great. So it is, in fact, not a coincidence, as usual. It is matter of fact that the probability that x equals k is the combination of n, or in this case, what is 4. So n being the number of trials, okay? K, n choose k, which is what we are doing here. You know, this is 4 choose 2. This is 4 choose 3, okay? Similarly, n choose k times the probability of success. So small p to the power of k, which if you see here, this is our probability of success. Okay, this is 4 1 times, so this is 4 choose 1 times 3 to the power of 4 times 3 times 1 to the power of 4 times 1. Okay, so this stays, and for example, this stays, okay? So that stays true. And then you have 1 take p to the power of n take k. So 1 take p being the probability of success or a fail is 4 take 1 in this case, a 3. 4 take 2 in this case, a 2. 4 take 3 in this case, a 1. Okay? So even that stands. And if you even look at the other ones, that also stands. So this is the probability of k successes for n trials in a binomial distribution, okay? For a binomial distribution, for a binomial variable. Just before we top off, okay, I am going to show you how to say that last part after the formula very quickly. We can say that x is distributed binomially, so bin or b, for n trials with p probability of success, okay? And that is all you need to know for dealing with binomials and working with them. So yeah, great. Now we can move on to other stuff. I believe the next thing is continuous random variables. So infinite possible options. Let's see how we go with that. Practice this and be ready for the next one.